In the space of science and gigantic privileged insights into the topic of existence ahead of time, the huge impact has blended conversations and intrigued characters for quite a while. This Goliath's request tests more than just our methods, it could separate the universe from itself. It challenges the genuine farthest imperatives of human data. Imagine standing at the edge of existence, examining the gigantic shadowing, and considering what was there before our universe was imagined. The event of the Big Bang marked the beginning of history, space, and what we know. In any event, there was a moment sooner, in advance. This may have eventually been a condition of nothingness, a calm before the bombastic gathering began. And assuming this is legitimate, was it truly nothingness? Or perhaps there was something significantly more upsetting that existed before time itself. As we skip ahead to the science of this request, it takes us on a journey past the universe's beginning stage into thoughts that challenge our mindfulness. Physicist Brian Cox, known for his commitment to uncovering the universe's wonders, suggests that something shocking might have existed before the Big Bang. He moved us to reconsider how we perceive the real world and existence. In this evaluation, we'll dismantle the science, the speculation, and the astounding insider secrets that might reveal what existed before everything. We'll explore contemplations like godly improvement, quantum changes, dark energy, and even multiverse. The revelations we uncover might just stifle you, but they could also open new understandings of our place in the universe. Plan to plunge deeply into the realm beyond imagination and science, where the dark still wins around the shadows, leaving scientists shocked and sometimes even unsettled. We ought to examine what existed prior to the Big Bang and why these theories challenge everything we thought we knew. To appreciate what could have existed before the Big Bang, we first need to understand what the Big Bang actually was. The Big Bang, as described by science, refers to the event when the universe became extremely hot and dense, expanding rapidly to set off the formation of all matter and energy. When we look at the night sky, we see evidence of this hot beginning, with galaxies spreading out from a single starting point. But why did this occur? Was there a time before this dense, hot start? According to the concept of cosmic inflation, there was, without a doubt, a before, and it was far from void or silent. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, fundamentally like a vast vacuum. However, this vacuum wasn't completely empty. It contained a massive amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so rapidly that it essentially established the foundation for everything that would follow. In a fraction of an instant, space expanded at unbelievable rates until inflation slowed down, and the energy transformed into matter, particles, and the forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly foster the universe, and for what reason did it stop? Scientists believe that this boundless expansion created patches of the universe, each undergoing its own Big Bang. Think of a fabric widening ceaselessly, with minuscule air bubbles forming. Each bubble represents a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially infinite Big Bangs and an endless number of universes. Our own is only one of many. This vast, mind-bending reality challenges our ability to comprehend the very universe itself and leaves us with the question, what else is out there? The concept of nothingness before the Big Bang is theoretical, not real, at least not according to our current understanding. Even if you remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and various forces that weave together a complex masterpiece of something. Even in its emptiest form, the universe still has structure. Regardless of whether we imaginatively strip away these forces, leaving a dead space, the universe would still generate new forms of energy. This reality baffles scientists, as it suggests that absolute nothingness may be impossible within our vast cosmos. Space itself possesses properties, rules, and constants that prevent it from being completely void. Imagine creating a region with literally nothing in it, no particles, no radiation, no energy. Yet, quantum fields and universal constants would still exist. For instance, there's a concept called zero-point energy, which represents the lowest possible energy state of quantum fields. Even in this state, particles can appear and disappear, creating a mysterious resonance of activity even in what should be empty space. This challenges our understanding of a true void and suggests that, yes, even before the Big Bang, there was something. Scientists are only beginning to appreciate one of the most astonishing speculations in modern cosmology, the possibility of eternal expansion. If inflation could create our universe, it's possible that it could continue indefinitely. Brian Cox describes an extraordinarily vast inflationary multiverse, where universes are endlessly created and expanded. Imagine each Big Bang as a spark lighting another universe, while inflation occurs in different regions, creating numerous additional universes. This cycle could, in theory, happen forever. This idea of enormous universes birthing others leads to the fascinating concept of a fractal universe, where each new universe may, in fact, create its own Big Bang. Every universe exists as an independent space, unaffected by the others. For researchers, this hypothesis is both exhilarating and unsettling, as it suggests an infinite multiverse with no clear beginning or end. Imagine our universe as just a tiny fragment of a vast, boundless tapestry, constantly developing and creating new universes. And what if that's the true nature of reality? There may be no before or after, but rather an eternal cycle of universal formation. Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not merely a collection of matter floating in space. Rather, it is a complex interaction of energy fields that fill the cosmos, creating everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even in their lowest energy state, the so-called vacuum state, they remain active. Particles can spontaneously appear and disappear in these fields, briefly borrowing energy before returning it. This phenomenon leads to the existence of virtual particles, substances that momentarily exist, then vanish, leaving only faint traces of their presence. The concept of virtual particles challenges the idea of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have nothing? According to quantum field theory, you wouldn't. Even in a vacuum, fields remain dynamic, sometimes creating temporary fluctuations. This ongoing particle activity in what should be nothing suggests that the universe doesn't conform to our traditional understanding of emptiness. Fields and forces persist. The process of compression and expansion in a cyclic pattern would mean that our universe is not the first nor the last, but rather part of an infinite series of cosmic rebirths. In this model, the universe expands until it reaches a certain limit, then contracts, eventually leading to another Big Bang. This theory challenges the traditional idea of a single origin event and instead suggests an eternal cycle of creation and destruction. But if the universe is part of an ongoing cycle, what drives this process? Some scientists propose that dark energy, which currently accelerates the universe's expansion, might eventually weaken or even reverse, pulling everything back together in a big crunch. If this happens, the cycle could begin anew, with a new universe emerging from the collapse of the old. Cyclic cosmology offers an alternative perspective, one that suggests time itself may be infinite. If the universe has always existed in some form, then the question of what came before the Big Bang may not even be relevant. Instead of a true beginning, there may only be an endless chain of universes, each giving birth to the next. However, not all theories suggest a repeating cycle. Some propose that our universe may have originated from another dimension entirely. The idea of a higher dimensional space suggests that our universe could be just one of many embedded in a larger, more complex reality. In string theory, for example, the concept of brane cosmology suggests that our universe exists as a three-dimensional membrane, or brane, within a higher dimensional space. According to this idea, two such branes could have collided in the past, triggering an event similar to the Big Bang. This raises the possibility that what we perceive as the beginning of time was actually just one event in a much larger, multidimensional process. If true, this means our universe may have originated from another universe, or even an infinite number of parallel universes interacting in ways we are only beginning to understand. These ideas, while theoretical, challenge our fundamental assumptions about time, space, and existence itself. What existed before the Big Bang? Was it nothingness, a previous universe, or an entirely different form of reality? The truth remains elusive, but as science advances, we continue to uncover deeper insights into the mysteries of our cosmos. Perhaps one day, we will find definitive answers. Until then, we can only marvel at the vast possibilities and the profound questions that drive our exploration of the universe. It means that there was never a true beginning but rather an eternal series of universes emerging, creating, and renewing themselves over and over. Cyclic cosmology raises profound questions. No time like the present, as it suggests that time itself might repeat rather than proceed. If this theory is correct, it could mean that what existed before the Big Bang was simply another form of the universe, one that fell solely to give birth to our current universe. For scientists, this theory offers a rich answer to the question of extreme origins, proposing that there is no clear beginning. The universe has always existed in some form, transcending our thoughts of time and existence. Gravitational waves are another interesting idea that could shed light on what existed before the Big Bang. These waves, discovered in 2015, are swells in spacetime brought on by extremely massive objects such as black holes or colliding neutron stars. These waves can travel long distances, carrying information about the events that created them. Could gravitational waves provide information about the birth of the universe? A few physicists propose that gravitational waves coming from the time before the Big Bang may provide insight into the state of the universe before inflation started. Gravitational waves from the early universe might leave clues that could help us understand whether the Big Bang was truly the beginning or whether there were cosmic events before that we don't yet comprehend. These waves could be traces left behind by events beyond our usual knowledge. Their presence could also hint at a grander structure beyond what we are familiar with. These faint signals might unlock pieces of knowledge that could change our worldview. Just as we discovered the Big Bang's start, what if they show the remnants of a past universe or an event that happened before the Big Bang? As scientists continue to research the deep reaches of space, the question remains, what existed before the Big Bang? With current theories pointing toward quantum mechanics, multiverse, and cosmic inflation, it seems we are closer than ever to unveiling the deep mysteries of the universe's origins. While the complete answer remains elusive, our understanding of what existed before the Big Bang continues to grow with each new discovery. As we explore these theories, we can also contemplate how they might fit together to show the big picture, the true nature of existence itself. But until then, we are left with the mystery, driving science and wandering into unknown places far beyond what we have yet known. As we continue exploring the question of what existed before the Big Bang, the idea of time itself becomes increasingly difficult to comprehend. Time, as we understand it, began with the Big Bang, making the concept of before somewhat paradoxical. If time itself did not exist prior to the Big Bang, can we even speak of something existing before it? Some theories suggest that time might not have a clear starting point and that our understanding of it might be limited by the current framework of physics. One of the fascinating aspects of these theories is that they open up the possibility of new laws of physics, ones that are not yet discovered or even imaginable within our current understanding. If the universe as we know it began with the Big Bang and before that there was a state of nothingness or cosmic inflation, then what governs the forces and particles in that pre-Big Bang state? Could there be an underlying layer of reality that transcends time and space, where the usual laws of physics break down entirely? This metaphysical layer would defy everything we understand about the universe, and yet it could hold the answers to some of the most profound questions. Some researchers have speculated that the beginning of the universe might not have been a singular event but instead could be the outcome of the interaction of higher dimensional forces. For instance, according to string theory, the fundamental building blocks of matter are not point-like particles but rather one-dimensional strings vibrating at different frequencies. These strings might exist in higher dimensional spaces beyond the three-dimensional space we can observe. If this theory holds any truth, then our universe could be just one slice of a higher dimensional space that intersects with others. The Big Bang, in this scenario, could represent the intersection of these dimensions, with a continuous cycle of universes being created and destroyed in higher dimensions. Moreover, theories such as the ekpyrotic model propose that our universe could have resulted from a collision between two higher dimensional membranes of spacetime that exist in more than 3 dimensions. These collisions, if they occurred, could have triggered a Big Bang-like event, starting a new cycle of expansion and contraction. Such models offer a framework for understanding the origins of the universe that doesn't rely on a traditional singular beginning point but instead presents a scenario of constant rebirth through cosmic events. This idea challenges our traditional thinking about the beginning of the universe and opens up possibilities for how it might evolve in the future. There are also intriguing connections between these philosophical and cosmological ideas, questions about the nature of existence itself. If time, space, and matter have always existed in some form, does this imply an eternal and unchanging reality beyond our perception? Or are we in the midst of an endless cycle of creation, expansion, and destruction? Some have even proposed that the answers to these questions lie outside the domain of science entirely and may only be fully understood through metaphysical or even spiritual inquiry. This suggests that the limits of human understanding might not just be about technological advancements in physics but also about the deep existential nature of reality itself. In conclusion, while we may never fully provide an answer to the question of what was before the Big Bang, the theories and concepts surrounding it provide a rich tapestry of possibilities. As our understanding of quantum mechanics, dark energy, and cosmology continues to evolve, we may inch closer to discovering the true nature of existence, time, and the universe itself. Regardless of whether the answer is grounded in science, philosophy, or something entirely beyond our comprehension, the mystery of what came before the Big Bang continues to captivate and inspire humanity's pursuit of knowledge. As we push the boundaries of our understanding, new scientific advancements may offer deeper insights into the origins of the universe. Current models of physics, including general relativity and quantum mechanics, provide frameworks for understanding the cosmos, yet they remain incomplete when addressing what happened before the Big Bang. A unified theory, one that successfully merges quantum mechanics with gravity, could be the key to answering this profound question. The search for a theory of everything. Physicists have long sought a theory of everything, a single, elegant equation that could describe all the fundamental forces of nature, including gravity, electromagnetism, and the strong and weak nuclear forces. String theory and loop quantum gravity are two of the leading candidates for this unified framework. 1. String theory and extra dimensions. If string theory is correct, then our universe may be just one of many that exist in a higher dimensional space. These extra dimensions, which are hidden from our perception, might have played a crucial role in shaping the early universe. If the Big Bang was merely the result of interactions in these higher dimensions, then our universe's beginning might not be an absolute starting point but rather a transition from one phase to another. 2. Loop quantum gravity and the Big Bounce. Another promising idea comes from loop quantum gravity, which suggests that spacetime itself has a discrete, atomic-like structure. This theory proposes that rather than a singularity at the beginning of time, the universe underwent a big bounce. In this model, a prior universe could have collapsed in on itself due to gravity before rebounding into expansion, meaning that what we perceive as the Big Bang might have simply been the latest in an eternal cycle of cosmic rebirths. The role of quantum mechanics in cosmic beginnings. Quantum mechanics has already revolutionized our understanding of physics, introducing concepts such as superposition, entanglement, and wave-particle duality. Some theories suggest that quantum fluctuations in a pre-existing quantum vacuum might have triggered the formation of our universe. In this scenario, what we perceive as nothingness may not be truly empty but instead filled with a seething quantum foam, an ocean of virtual particles appearing and disappearing within fractions of a second. If a random quantum fluctuation was large enough, it could have led to a rapid expansion of space, sparking the event we call the Big Bang. Cosmic inflation and parallel universes. One of the most widely accepted explanations for the early moments of our universe is cosmic inflation, a theory proposed by physicist Alan Guth in the 1980s. According to this model, the universe underwent an unimaginably rapid expansion in its first fractions of a second, smoothing out irregularities and setting the stage for galaxy formation. However, some variations of inflation theory suggest that our universe is just one bubble within a vast multiverse, where countless other universes are continuously forming. If this is true, then our Big Bang was not the ultimate beginning but merely a local event in a much larger, ever-expanding multiverse. The philosophical implications of an eternal universe. If the universe has no true beginning and has always existed in some form, this challenges our very concept of time and existence. It forces us to reconsider whether the idea of a singular origin is a human-imposed limitation rather than a fundamental truth of nature. Some philosophical perspectives align with this scientific idea. Ancient Hindu cosmology, for example, describes the universe as going through endless cycles of creation, destruction, and rebirth, an idea strikingly similar to modern cyclic models. Similarly, certain interpretations of Buddhist philosophy suggest that existence has no ultimate beginning or end but instead flows continuously in an eternal process of becoming. Even within Western philosophy, thinkers like Immanuel Kant questioned whether time and space are intrinsic properties of reality or merely structures imposed by human perception. If our understanding of time is limited by our own cognitive framework, then the question of before the Big Bang may be as meaningless as asking what is north of the North Pole. Future discoveries and technological advancements. While these ideas remain largely theoretical, future technological advancements could provide new ways to test them. Several promising avenues of research include gravitational wave observatories. Advanced detectors like LIGO and future space-based observatories could detect primordial gravitational waves, potentially revealing information about what existed before the Big Bang. Particle accelerators, the Large Hadron Collider, LHC, and its successors might uncover new particles or forces that help explain the pre-Big Bang state. Quantum simulations. As quantum computing advances, scientists may be able to simulate conditions before the Big Bang, testing different theories in ways never before possible. Cosmic background radiation studies, more precise measurements of the cosmic microwave background, CMB, might contain subtle clues about earlier cosmic events, shedding light on pre-Big Bang physics. Conclusion: the mystery continues. While science has made extraordinary progress in understanding the universe's evolution, the question of what existed before the Big Bang remains one of the greatest unsolved mysteries. Whether the answer lies in higher dimensions, quantum mechanics, or an eternal multiverse, each new discovery brings us closer to uncovering the true nature of existence. Perhaps the ultimate answer will not come solely from physics but from an intersection of science, philosophy, and a rethinking of our very definitions of time and reality. Until then, the mystery of our cosmic origins will continue to inspire generations of scientists, philosophers, and dreamers alike.